Let's look at what we have from the point of security. Security is a process. What do I mean by that? Right? It changes dynamically. It's not like you do one time. It's not like you set up your cluster today, maybe follow the benchmark, follow the best practices, and you're done with it. Because there are a lot of things involved. Things change. A lot of things change dynamically, and then with that changes, you have to keep evolving, right? To meet the risks, to mitigate what risk which comes with everything. At the very high level, you have your assets, your physical assets, maybe, right? So in that case, you may have to protect it physically. That your computers, your printers, or all of your assets, what you have. There are different types of assets, maybe involving hardware, maybe involving your software, data, or maybe your data, your process, maybe your staff as well, right? Or it's a combination of all of them. All of them integrates into your asset lifecycle security. Maybe it begins with acquiring your assets. It's important that there is a chain of custody of of physical assets, up to including when the asset is powered on and stuff like that. Then security is also integrated in your software development as well, right? What kind of tools do I use to uh, build it? Do I have enough cycle to understand the design, the development, the testing, and deployment as well? Right? It's crucial that security is considered during the design phase of the project itself, so that I don't have to worry too much around it. And as an established organization, I need to have policies and procedures in place to establish, the best practices, and to protect myself from the risk of accidental or the intentional harm. Right? We also define and control the roles and responsibilities. It is important for an establishment to have a hierarchical structure for your incident response. Right? There needs to be a defined leader or a plan for assigning your, if you encounter an issue, what you need to do, and stuff like that. The point I was trying to make is security is not a one-time activity. It's a constant process where it involves different phases of your application and different stakeholders as well, like your physical assets to your software assets to your data to the development lifecycle, to what kind of policies you have defining your security, and then what kinds of roles and responsibilities you have around that as well. And it's kind of a process. It's ongoing. It's not one time. There are different types of attacks what we have. Let me quickly talk about few of them, right? Well, with threat model, what we talk about, like threat modeling is a process, right, where we identify kind of vulnerabilities, and then so that we can put a measure, right, in a place to prevent and mitigate them. What do I mean by mitigate? What do I mean by threat? A risk is like maybe a potential problem which can affect, and if that happens, and there is a threat, right? Threat is a path to your risk, if you look at it that way. And mitigation is maybe like a countermeasure against a threat. If something is going to happen to you, what can you do to prevent that threat to happen, or at least reduce the likelihood of its success, or at least reduce the impact of that as well. So there are different kinds of threat modeling what we have. Stride is what we have, right? Stride, I mean, when I say stride, I'm going to quickly bring out the notepad real quick. One of the model, we're going to take a look at few things around this as well. That's the reason I want to bring this out. Let me maximize a little bit. We call it as STR. We're talking about general security per se, nothing related to Kubernetes for now. Spoofing stands for S. Stride is the easy way to remember. That's what they call it as well. We've got to worry about spoofing as well, right? I can maybe mimic myself. When I'm talking about secure, let me write down what they mean, and then we talk about it. What I am, there's tampering. There is a reduplication. There's denial of service. There is elevation of privileges. All right. So there are different threat models. Threat modeling is a process of identifying your vulnerabilities so that you can put measures in place, like your countermeasures, right, which prevent them, and then you can mitigate them. Right? So the way you look at your security, there is a popular STRIDE model, STRIDE, and then we see how you can apply that in your Kubernetes. That is, if I really have to break it down, the CKA syllabus around it kind of falls around this threat modeling, where we try to protect each things. For example, if I bring up spoofing, right? Spoofing is like pretending to be something or someone you are not, right? We've generic word what we do, like your emails get spoofed and stuff like that. I said the communication between all of your components, or maybe communication between your API server is secure, and maybe I can, I can mimic that as well. I can, I cannot be the one what I'm talking about. I can maybe get a self-generated self-signed certificate and then try to, cheat or try to fool my API server by, mimicking me as somebody else. That is just spoofing, right? Maybe by securing your pod communication, maybe I can represent myself as somebody else and try to get information out of it. And we were going to see how we can do that. We can do tampering, right? That's tampering is act of changing something in a malicious way. And with respect to the security, the goal of tampering would be usually to cause your denial of service or elevation of privileges and stuff like that. Maybe the tampering with your Kubernetes components, maybe tampering with your configuration files for your API server, your controllers and all of them, or maybe tampering with your container runtime or your Kubernetes runtime binaries. We're going to take a look at that, how we can prevent that as well, right? So there are different ways of tampering things with ourselves. Uh, then we have your information disclosure, where we try to protect our cluster node data, or we try to protect our data in the pods. We do that with trying to restrict the access to our pods. Then there is denial of service, DOS attacks, right? To make something unavailable. There are different kinds of denial of service of type of attacks. We're going to see how you can contain that, how you can prevent that from happening. One such way, maybe just to give you an example, right? By default, our containers run and they run as a process on our host, and they can consume as much as memory and CPU they need, right? That's a default behavior. If I don't restrict that, they can consume as much as memory available or as much as CPU available on my host. And then if an attacker gets access to my container, he can then start exploiting some features and start maybe consuming a lot of memory and CPU. And if I've not limited how much my container can consume, I would maybe end up consuming a lot of memory on my host, denying other containers and other processes, starving them out of memory. And that would maybe lead to a situation of denial of service, where one container is consuming so much of your compute and resources, the others are starving, and you have you know denial of service. How can we prevent that? We were going to take a look at all of that in this session, right? We also have privilege escalation, where you know where we prevent people from elevating your privilege. Elevation of privilege or privilege escalation is gaining a higher access than what has been granted. How can you prevent that? The more the access I get, I can cause more damage. If the gain is unauthorized, then I'm at risk. So we have different ways of doing that. Maybe using the webhook, or maybe using the airbag and stuff like that. We're going to take a look of all of that. Just want to introduce to you this stride model, and this is where most of our course, the CKS, is kind of defined around this kind of threat model. Talking about types of attack, we have active and passive attack. An attack that refers to active is when attempt to alter your system resources or affect their operations, compromise their integrity and availability. Passive attack is like attempt to learn more information about you or your systems or your nodes, which compromises your confidentiality but does not really harm or does not really make your services unavailable, but your information is compromised. There are 4 C's of security. What do I mean by that? If you look at the diagram, at the very low level we have, or I can say the level 1, I have my cloud, my infrastructure, right? It can be my cloud, your corporate data center, or your infrastructure which is coming out there. It is always important for me when we talk about security. There are different other pieces, right? When I'm running my cluster, if I just secure my cluster and if I leave my loopholes in my infrastructure, it makes no sense to me, right? So it's all the team game. We got to worry about all of the 4 C's. Each level is dependent on each other, and then it's not only important that we have a very good tight container or a very nicely written code which follows all these security standards, but if we have loopholes and even at the cluster level or the data center or the infrastructure level, then I am exposed, my whole application is still compromised, right? We're going to look at how we can protect these. We're going to look at few of them when it comes to your cloud or your infra. Like for example, we have to worry about your networking, you have to worry about your firewalls, your rules around them. That usually when you have a hosted Kubernetes solution is taken care by your cloud provider. You don't have to worry about it. From our exam point of view as well, we don't have to worry much about your data center or your physical infrastructure like your computer, your operating system, and your networks per se. It is your network or your system administrator's responsibility to harden your servers. Of course, we know what we need to do. As in, when I say maybe few ports may be open, we will look at that from from that angle of how do we protect our physical or your infrastructure per se, your computers and networks. We're going to take a look at that, but the responsibility of hardening the system mainly lies with your with your server administrator and stuff like that, right? But from the CKA's point of view, we look at what things are important, what can we do to save that. At the cluster level, we can look at who is authorized, who is authenticated, right? Maybe I can use of admission controllers, which can maybe validating admission controllers or mutating. We can look at that from the cluster point of view, right? Who can run what they want to run? How can I prevent from unauthorized user accessing my cluster and running things? How can I give appropriate roles to authorized user? I might be authorized user, but I should not be having more privileges than what I need to have, right? If I'm the person tasked with monitoring, I should not be having rights to maybe go and edit your secrets out there. So there should be appropriate controls in place of defining roles and then assigning those roles to user to authorize and authenticate them. We are going to do that with respect to the cluster level, right? We are going to take a look at maybe network policies at the cluster level. How can your containers communicate? How can you prevent containers from talking each other? How can you create that isolation? We are going to take a look at that with respect to the cluster, right? At the container level, what do I mean by the security? I have a secure cluster. I do all the authentication, authorization. I have a secure data center or a secure infra level. On top of it, I have a cluster which is much secure, has all of your, access controls in place. But in the container, if I'm running the images with vulnerabilities, or if I am, when we spoke a little bit about the containers which gave us the isolation, like just like the virtual machines gave us the isolation, virtual machines really gave us a very tight isolation where two virtual machines had nothing to do in them. They never shared any uh, other than what they were running on the same physical infrastructure. They really had nothing in common in them. They were not sharing the operating system kernel per se. Containers, they share your host machine's operating system. So in that way, they have a link talking back to your kernel. And if I know, if I can exploit any kernel vulnerability and I can skip out of my container and go into the kernel, then I have access to the whole server. Then I can talk to other containers as well. So we got to protect our containers. We got to sandbox them. We're going to see how we can prevent containers, how we can prevent the attacker from leaking out of the container. Maybe putting them against in some kind of a sandbox, right? Maybe some kind of sandboxing. Maybe we can do certain things like we prevent them from doing a lot of system calls. Maybe we make use of different security options what we have of wrapping them up. Maybe we restrict the images what we can pull, what we can run in the container. I have a secure cluster, secure data center, but I am not securing what kind of images I can run on the container. Defeats the purpose, right? If the user can download images which has malware or which has viruses in them, it compromises my whole application, right? Whole application and my cluster and stuff like that. So we got to take protection around how we can restrict what kind of images are being pulled, how we can worry about scanning your images for vulnerabilities, how you can take care of your supply chain from the build to your image download process, how I can make sure they are secure and safe. We look at sandboxing, we look at privileged mode, how we cannot, even an attacker escapes out of the container, he should not have enough privileges to cause harm, right? The different levels of it. From the code point of view, I can look at, of course, you can write your code in any of your favorite language. We are not going to go there when I say code point of view. We're not going to teach you Pythons and Javas, but when you make use of certain sensitive information, like for example, your secrets, your tokens, your TLS certificates, how can you make use of them? How can you not hard code them in your source code? How can you leverage your Kubernetes features like secrets and config maps? How can you secure them is what we are going to take a look at. It. Each of these phase is interconnected with each other. If you have the very secure code, but you have not sandboxed your containers properly, then you're still at the risk. You have all of them done, your cluster is not secure. So the point I'm trying to make is all of these steps are interdependent on each other. And in this class, what we're going to do in the CKA sessions, we're going to learn few of them. We're going to learn all of them when it comes to container and code and cluster. When it comes to your infrastructure, we're going to take a look at few things, maybe at the firewall, at the port level, or maybe at analyzing the log level kind of a deal, right? So that's the theory of what we were talking so far. I was just showing you the picture, the 4C's of security. You have each layer affecting the other layer within. One cannot protect everything from the code layer if there's a vulnerability in the cluster layer. That's what I was trying to tell you, right? There are many cloud providers. Each of them have their own security best practice, and I don't have to worry about them, because if I'm taking the hosted Kubernetes solution, if I'm taking the cloud provider, I mean, each cloud provider has their own mechanism to prevent it. Then I should know what kind of cloud provider I am. I have to look at their documentation per se. And we are focusing more towards Kubernetes kind of security, which even if you're running on your hosted Kubernetes solution are applicable. Most of them. Few of them, when it comes to your physical or your infrastructure level, might not be available because you'll have no control over them. That's managed by your cloud provider. The other aspects of your Kubernetes, of how you can or your image or your container supply chain or image supply chain, we're going to take a look at all of that.
So guys, this was a clip taken from our step-by-step comprehensive program that has 16 modules, 60 plus lessons, 35 plus hands-on labs, CV and exam preparation, and the most important, on-job support. So this comprehensive program is specially curated for you so that you can be from beginners to a master, and you can master every skill set that has been required here. And if you're somebody who would want to start off their career in the domain, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get you higher paid jobs. And don't you worry, this interactive session will help you in gaining the understanding of why learn containers and Kubernetes, what is Docker container architecture. We'll be discussing about pod with highly available and scalable applications on Kubernetes. We'll be having demo so that you can perform really, really well. And now if I'm talking about that, what special do we offer? We have the comprehensive learning path for Docker and certified Kubernetes administrator course. So in week 1, we'll be talking about microservices and Docker. Week 2 is about Docker, networking, storage, and app stack. Week 3 is about Kubernetes architecture and installation. In week 4th, we discuss about security, troubleshooting, and high availability. Week 5th is about networking, that includes all the networking policies, securities, contexts, and whatnot. And one thing that I have to mention here is that with every session, we have labs so that you can practice whatever is being discussed in the class, and this give you a knack over everybody because you will have the practical knowledge. Coming to week 6th, we are talking about deploying of daemon processes and whatnot. Week 7th is about application stack. Week 8th, we talk about advanced networking, of course, followed by some different laboratory sessions. And in week 9th and 10th, we are completely focusing on your certification preparation. That includes project work. Then we have certification practice part 1 and certification practice part 2 as well. And in week 11th and 12th, this week is completely dedicated for your CV preparation and your project work, because project work is something that is going to help you with all your exams and of course interviews as well. And now talking about the hands-on labs, and as you can see on the screen, we have almost every topic covered. So with every topic, you'll have a fine-grained understanding of whatever topics we are covering, and each topic you can have a practical knowledge that is going to help you in your examination and of course in your jobs. We also have sample exam papers in PDF format, and here you can definitely see on the screen that what kind of questions we have, and these questions are going to make you prepared for your exam and your interviews. So if you really want to have a basic and if you really want to see what all we are going to cover, then we have this free class where we'll be talking about why learn Docker and Kubernetes and Docker containers architecture, image and containers and whatnot. So if you want to register for this free class, then just have to log on to K21Academy.com/K8S02. You'll be seeing this kind of interface. Just click on book your free seat now, select an event date, add your name, your email address, your phone number and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface where you just have to save this link on the extreme right, add it to your calendars, and I will see you in the free class. Till then, keep learning.